Let me tell you a story. 1981, IPv4 was invented. It had 4.3 billion addresses. The goal was to give every internet-connected device a way to talk to every other internet-connected device. The internet was small back then, only being used by universities and government workers. It was called ARPANET. That was about to change, though. In 1989, the world's first ISP is called The World. 1992, 1 million hosts are connected to the internet. 1993, Bill Clinton does email now. 1994, uh-oh, pizza time. Hey, Secret Service guy, it's me, Bill the President. You want pizza? Yeah, I love pizza. Pizza Hut's doing online orders now. Pizza. Do they do pepperoni? 1996, internet now has 10 million hosts. Are we going to run out of IP addresses? We just keep giving like 16 million of them to any jester who asks for them. Like, look at these two. Aren't they supposed to be busy building boats and stuff? That's Blaze, just wipe the slide. The architects of the internet have been on the case since the early 1990s. They've been making things like classless interdomain routing and network address translation. But then, in December 1995, the permanent fix was proposed. With 340 undecillion addresses, we have it. IPv6. That's an absurd number, by the way. You could give an IP address to every single grain of sand on every beach on the planet. The number would be unchanged. These first 15 numbers would be completely unchanged. I'm sure there was someone talking about IPv4 that way back in the day, like, wowie zowie, 4.3 billion addresses, talk about overkill. And then he turned into sand. So what does address look like? Good question. The address looks like this. It is 8 groups of 16 bits each, and they're hexadecimal. Stand back, I gotta chop it in half. This first section is the network ID, and it is made up of the global routing prefix and the subnet. This bottom section is the interface ID. That's your device. The interface ID used to be based on your MAC address, which is unique to your device. This made each IPv6 address automatically unique. Translation between your MAC address and the interface ID was the same every time. It basically looked like this. But as it turns out, making your device's physical address visible to anyone made your device much easier to track. It was very unsafe, so they fixed that by making it pseudo-random. Your IPv6 address is determined by your device and the network ID. It then checks to see if the address is taken. The address space for IPv6 makes it so unlikely for anyone to have the same address that it's actually just faster to claim an address and then check rather than the other way around. So we got a big ol' address right here. We need a way to shorten it. Got it. Remove the leading zeros from every single group. Pretty stubby little guy, right? We can shorten it even more though. We can use double colon notation, which is when you get rid of all of these zero groups and condense them so that the address looks like this. I emphasize that you can only use it once per address though, and I'm going to show you a little demonstration. Let's say we take this address from the second step and we make the 6th and 7th group turn into zeros. Let's use the double colon notation twice to make it 1080:8:417A. This does not work because it could re-expand into multiple addresses. I know what you're thinking, and the answer is yes. An address of all zeros does just shorten to 2 colons. In fact, the IPv6 loopback address, the one that your computer uses to send information to itself, is ::1. So how many users are using IPv6? The biggest user is France, with nearly 90% of Google users having IPv6 addresses. Second place is somewhere in the mid-70s. I think it was Germany. It was like 77. However, the overall usage statistics tells a different story. The highest reported IPv6 usage is around 49.9%. If it goes above that, it's not my fault. You gotta stop blaming me for that. This video has like 10 views, like wake up. So why aren't a lot of people using IPv6? Well, in the early 1990s, IPv4 address exhaustion was an issue that was needed of a quick fix. The solutions would need to be in place until the permanent fix was ready. The big solution was network address translation. The goal was to stop giving every endpoint its own IPv4 address and instead give a public IP address to the router and give private IP addresses to the endpoints so the router can send along information to them. It's kind of like, your mailman doesn't really need to know who Bob or Billy are. They just need to know that they both live at 1234 Dude Avenue and then put it in the mailbox. It's the person who retrieves the mail and puts it under their door that needs to know who Billy and Bob are. In this case, the router is kind of like the mailbox and the person retrieving the mail, and the mailman is your internet service provider. So yeah, why aren't more people using IPv6? I mean, sometimes the bandage solution just works. Network address translation creates a gap between the devices in a home or office and the greater internet. It could also be very expensive for some organizations to move over to IPv6, since they would need to have IPv6 devices in order to do that. That's all I got for today. Thank you so much for watching. I've got all of these sources in the description.